Hello and welcome to IP addressing worksheet number 3. In this worksheet, I want you to be aware of special IP addresses that may come up and either on exams or when you're configuring devices. There are three different types. There are the reserved ones, private IP addresses, and the automatic private IP. The reserved one, let's start with the reserved one. There are three different reserved IP addresses. Reserved IP addresses are IP addresses that cannot be assigned to a host. And there are three of them. There is the network address, the broadcast address, and the loopback address. So a network address, a broadcast, and a loopback cannot be assigned to a host. You can't give this to a host. The special IP addresses. A network address is the IP address that identifies the network. So everybody in the LAN shares the network portion of the IP, and the host portion will identify who you are in that network. So when you say what network that I'm in, you will identify your network address, but you make sure that the host portion is 0. So if the host portion is equal to 0, that's your network address. So therefore, you cannot assign that address with a host portion equal to 0 to any user. The router, the devices, the host, the workstations will reject it. Okay, so what do you need to know? You need to know if you are given an IP address, you need to identify if it's a network address or not, or someone will say, is this a network address or not? So this way you will not be able to, you will not be able to assign it to a host. Okay, so an example would be, how would you find out the network address of this IP? 192.138.250.45.34/24. So we did it on the last worksheet on how to find the network address. So what you do is you take this number, 198.138.45.34, and it, do the logical and with /24, and then you'll get 198.138.45.0 is your network address. So this address cannot be assigned to a host without 0, but that identifies everyone in the network 198.138.45. Right? What's the network address of 192.168.38.204/27? Or the network address comes out to be, after you do the ending, is 192.168.38.192. Remember, /27 says that the first 27 bits of the 192.168.38.204, first 27 bits are your network address. The rest is your host. So if you break this up into binary, 192.168.38.204, it comes out to this, right? Like worksheet number 1. And as you can see, the first 27 bits is this. That's the network address. From up to here. See, the red ones are your host portion. It has to be all zeros. This is actually how the devices sees the IP address. We write them out in decimal format. Your computer or your router or your switches will convert them into binary automatically. That's what they work with. And they see that the last 5 digits are 0, so that must be the network address. So if you type in this IP address with /27 on a router or a host, it's going to be rejected because it's a network address. By the way, if it was /26, let's say, that means it'd still be a network address because it's still 0. If it's /25, then the slash ends up right here because that means there's a 1 in the host portion, right? And that will make this if you change the mask to /25 instead of /27, it would be a host address because the host portion is no longer all zeros. Okay? So that's how someone asks you, is this a network address or a host address? So what you do is you have to break it up in binary and look at, and then put a wall. Where's the /27, for example? Here, right? You count how many bits and you stop, and you look at the right-hand side. Is it all zeros? If it is all zeros, it's a network address. If it's not all zeros, then it's a host. Now, if it's all ones on the other side, then it's a broadcast address. Okay, so what is a broadcast address? A broadcast address is a packet that is sent to everyone. So that's where you take your network address and you replace the host portion with all ones. And that will be your network address. So for example, this address right here from the top, what's the broadcast of this address? So what you need to do is take the network address, which is 198.138.45, and replace the last 8 bits, which is the /24, that are zeros in the network address, replace them with all ones, they become 255. So this is your network address. This address again, 198.138.45.255, cannot be assigned to a host. Why? Because this is the address that any device in this network, 198.138.45, can stamp this address as the destination on the packet, and when he sends it out, everyone in the network 198.138.45 will receive that packet. That's a broadcast address. Okay? Now remember, it doesn't have to be 255 at the end. Remember, only the host portion has to be all ones. So here's a typical broadcast address. For example, if /27, what's the broadcast address of this? 192.168.38.204. So as you can see, when you do the ANDing, right here, you'll get 192.168.38.192. And then, because the last 5 bits are all zeros, you replace them with all ones, and when you read the last byte, instead of 192, it becomes 223. So 192.168.38.223 is your broadcast address. See, it's not 255, right? Because the last 5 bits of the /27 is all ones, then it's a network address, right? So somebody gave me this address right here, 192.168.38.223, and has a /27 address, and says to me, is this a network address, a broadcast address, or a host? What do? You don't do any ANDing. If somebody asks you, is this a broadcast, a network, or a host? So what you do is you take the IP address, convert it into binary, okay, put the first 27 bits on the side, that's the ones that are not in red, and then look at the last 5 bits, the host portion of the IP. Are they all zeros? No, so it's not a network address. Are they all ones? The answer is yes. If they are all ones, then it's a broadcast address. By the way, if they are not all zeros, that means it's not a network. If they're not all ones, that means it's not a broadcast. Then it must be a host, right? All right, loopback address. The final reserved address that cannot be assigned to a host. You should say first. If the first byte in the IP address starts with 127, then it's a loopback address. A loopback address is used to really test the local host for connectivity, or sometimes we say we're testing the TCP/IP stack. It doesn't matter what you write after it, by the way. So typically it's written 001, and I'll give you an example. So here, I'm going to go in and go to the command prompt. Let me see. And if I say ping 127.0.0.1, again, as long as you start with 127 and you hit enter, what you're doing is you're asking your computer to go to the network layer, create a packet, stamp on it 127.0.0.1, encapsulate that packet in a frame, go to the physical layer, put it on the physical layer, and loop it back. Don't even send it out. Loop it back, open up the frame, and pull the packet out. That's where looping back comes in. So you're testing to see if the software, the TCP/IP stack in your part of your operating system is able to encapsulate a packet frame it, being able to try to send it out on the media, and being able to also receive a frame on the physical layer, open it up and pull the packet out. That's what you're testing. You should get a reply. You don't have to be connected to any network to be able to test the loopback address. So that's your first troubleshooting when you are trying to figure out why a device is not connecting. The first troubleshooting step is ping the local host to make sure that your software, your TCP/IP stack, is operating correctly. If you do not get a reply, then you got problem with the host. It's not connectivity with anything else. If that works, then you try to ping the default gateway and see if you can communicate with the default gateway. If that's successful, then your problem is outside your LAN, not inside. Okay? So the loopback address again is only to test the internal, to test the local host for connectivity. Private IP addresses. Private IP addresses are designed for inside the LAN. Because we were running out of IP addresses, they've decided to, the IETF decided to keep the network, create a block of IP addresses where networks can use it without having to worry about registering these IP addresses. Now these IP addresses can only be used inside a LAN. If you need to go outside your LAN, like for example onto the internet, you need to convert those private IP addresses to global ones. And the ones that enable you to do that is the Network Address Translation Protocol. So NAT is usually running on your router. And so you can use your private IP addresses, any IP addresses that starts with 10, 172.16 to 172.31 or 192.168. X is that means that it doesn't matter what that number is. As long as your number, for example, starts with 192.168, then it's a private IP address. It's a private IP address, and you won't be able to get on the internet with a private IP address such as the one that starts with 192.168, for example. That's your source IP address. So if you send a packet with the source IP address that's coming from inside the LAN, starts, for example, with 10, then the router will remove that IP address, the source IP address, from your packet and give you a global one. That's what NAT does on the router, and let you go outside. And when you come back in, it's going to translate you back to your private IP. Right? Why is this good? Because it allows us to have more global IP addresses. Only when you want to get on the internet that you'll be translated, get on the internet using a private IP. Now, you just need to be able to recognize which is a private IP address and which is not. Just remember, private IP addresses are not used, or they are not routable on the internet. They have to be translated into a global address to be able to access the internet. Okay? By the way, IPv6, when we talk about that, there's no need for NAT. Everyone will get a global IP address, and no translation is required for IPv6. All right, so here are a whole bunch of different examples, but they are all private IP addresses, as you can see. All right, so you just need, for example, this is a broadcast. Second one right here is the private broadcast IP address, and so on. So you can take a look at it. APIPA, the automatic private IP address. In the old, this is with the old Microsoft operating system, some Unix. What happened is, when you turn your computer on and your computer goes and searches for a DHCP server, if it does not find one, and you still need to be able to communicate, what your operating system is, it created an IP address automatically for you called the APIPA, the automatic private IP address, to enable you to communicate with devices inside the LAN. But that's APIPA, the APIPA address, you cannot use it to access the internet either. So, in other words, if you go into a computer and somebody is complaining that they can't access the internet, and you went and you type ipconfig, and you see that their address starts with 169.254, dot whatever, then you know that your computer has generated this address just to enable you to communicate inside the LAN, and because your device could not find a DHCP server, that's why it generated an APIPA. So you know that something is wrong with the DHCP server when you see that the device has an address starts with 169.254. So you go and try to figure out what's the problem with the DHCP server. Remember, the APIPA cannot be assigned to a host either, right? And it is not routable as well. That's why we call it a private IP address. In some cases, the device might not even give an IP address. You get all zeros. So not all operating systems assign APIPA when they cannot find a DHCP server or cannot find a static address that is assigned. Okay? So again, excuse me, going on the bottom, there's some exercises that you can play around with. So this one is figuring out the network address given an IP. So again, you just do the ANDing to figure out the network address. The second part, after you find out the network address, for the second part, all you have to do is go to the host portion of the IP, fill them up with all ones, and then reread the address in decimal format, and that will be your broadcast address. On the last part, all you have to do is be able to identify, is this, I know they are all private, by the way. So you need to say, is this a host, a broadcast, or a network? So all you have to do, don't do any ANDing right here. So what I want you to do, for example, on the first address, is write this number, 172.16.89.135. Write it in binary format, put the first 19 bits on the side, and then look at the last 13 bits. And are they all zeros? If they are all zeros, then your answer would be a network address. If they are all ones, then your answer will say this IP address is a broadcast address. If it's neither a network or a broadcast, then that IP address has to be a host. So the answers here are either network, broadcast, or host. Again, separate the addresses and look at the host portion only. Okay? So hopefully this will help. In the next one, the IP addressing worksheet number 4 will start to look at how to do subnetting. Okay?